I will try to show how in the bridge design I try to design extremely simple structures. No problem. I think personally that it is much simpler by some ways to design a bridge than a complex structure. As you have seen with Mr. Martin Rees, how complex is the interaction between the different profession for the erection of a large building. In fact, when designing a bridge, it's much simpler. You have practically, you might done the design mainly by yourself alone, and it's much simpler by this way. But on the other hand, you have to balance enormous loads, enormous forces, and on a very long distance. And I think that it is important that users feel rather safe and comfortable with these structures, and for this reason I think that it's necessary that they see how the structure is working, how the loads are transferred, and for this reason I think that it's logical to make something extremely simple, extremely clear. Thank you very much. So I shall, now that the PowerPoint is coming, hope so. I shall show very quickly some bridges on the motorway which we have designed. Okay. Can you put it full screen? I'm an engineer, but I don't work with computers. I'm very sorry to tell it. So I need some help for that. Yes. But it was, it's not on the hard disk, no?
I saw the hard disk is still reading.
It's still reading, okay. Oh. Wait, can I pass the second one? No. It is located on the A75 motorway, which is the second motorway to bypass the motorway which exists on the Rhone Valley and which is completely congested. The second goal of this motorway was also the development of this massive central, which is a mountainous area in central France and which was really underdeveloped and rather poor. This said, the big advantage is that all the local authorities were very much in favor of the motorway, absolutely against what happens very often now in Europe, where we have immediately Greens shouting against everything to build. In this case, we had a very strong support. In addition, this is the last motorway which was designed by the French administration. Now everything is built by private finances, what we call PPP, privately financed project. And so we took a very great attention to the quality of the bridges and also to the design of the road itself. I will not show any slide of that, but it's very clear that when you pass in some soft mountains, some hills, it's very good to have a road which is going very softly and very well adapted to the landscape, to the shape of the hills everywhere. I will show some of the bridges. I had the opportunity to be involved in almost all of them, either as designer or just to give some ideas or to be independent checker. The first one is a striking bridge. It's a bridge with inclined support, which is very over the river Truyère, very close to the Garabi Viaduct, which has been built by Gustave Eiffel. And one of the goals we had when designing this bridge was not to design an arch, not to try to fake what was done by Eiffel long ago. More to the south, we have two rather simple bridges, which have to be exactly very well located in the site. You see, this bridge is passing along a hill. It is just with a small talweg falling down from the hill, and we just try to adjust very precisely the position of the different piers in the site. For example, to have the two taller ones with almost the same vertical height. The structure is a box girder, rather narrow, rectangular, with very wide cantilever supported by a series of steel struts. The second one, built by the same company and with practically the same design, is on a different side because we are passing from a hill to another one, and so the bridge is, you can see the bridge in a very completely different situation. We try, all these bridges are extremely simple, but we try to produce some diversity by the structures we use, by the shape of the piers, by the colors. This one is a very simple bridge. This is a composite structure with two eye girders and a series of floor beams, very simple piers, and close to a village which is called Chirac, but it has nothing to see with the former president. Now, two small bridges. This one is at a pass between two areas in the hilly area, and the architect was working on this bridge before I came in the project, decided to design an arch to make, to insist in phases the location at the pass. And then when I proposed them to design a tubular arch, that is, this bridge is only made by a tube, which is a segmental tube, and which is carrying a press-stressed concrete slab on top through a kind of small tubular truss. Just close by, there was another passage to cross, and this time to make something in complete opposition with the previous one, which is a pure compressive structure. I designed a pure tensile structure. This is, this time again, a press-stressed concrete slab, but which is supported from below by a series of cables which are tensioned, and the geometry of the cables and geometry of the steel struts which are deviated by the cable produce exactly the forces, the loads to carry, to lift, in fact, the press-stressed concrete slab, exactly the same forces as would have been in a support. A very small one, which is seen by nobody, just a small two-span press-stressed concrete bridge, which is made by a series of 4 rectangular ribs, which are at a slightly equal distance longitudinally to adapt to the skew of the crossing. The last but one on this motorway, of these big bridges, is the most important except for the Mur Viaduct. This is the Verrières Viaduct, a bridge which is about 1 kilometer long, which is close by a small medieval village, and the first decision was to place the bridge at a distance large enough from the village not to disturb too much the inhabitants, which is also something that we have to consider very seriously. This bridge has spans of about 140, more precisely 144 meters, and the piers are about 150 meters high. Of course, this, you see that for these such high piers, such tall piers, we have important wind loads, as we shall see again for the Mur Viaduct, and the shape of the pier is adapted. We have, of course, we need match width at the bases to resist the important wind bending moments coming from the wind forces on the deck. These shapes have been, you see, once again, as we shall see again later, we have to make these shapes in such a way that they are elegant, that they are variable shapes, but in the same time that we can build them with rather classical formworks. In this case, I hope there is another slide, yes. In this case, the lateral parts are of constant dimension, and we are just acting, sorry, I think it's a pointer, yes. We are just acting by widening the central part, in fact shortening because we begin by the lower part, to make this variable dimension in the same time as we control the equipment to erect the structure. The box girder is a composite bridge.